In this video, we're going to discuss about this Lab4, which is an assembly program that performs left shift and right shift between two numbers. It implements the bitwise left and shift operations. So to start with, we have this include ism.io.inc. So we have this one since the assembly program doesn't have the printout options, and incorporated here are the different functions that we are needing in order to print out the results later on in our program. So let's start with this block. This is the segment.data, which contain 5 labels of different string values. So we have this enter a number, enter the number of places to shift, this left operation, right operation, and the word is. Next in this block, we have this segment.pss. So this one are labels that doesn't have any values yet, and we're gonna fill it in as the program continues. So to formally start, we have here the ASM main, enter 00 and push A. So this is like the default entrance of every function in our assembly. Let's proceed in line 33. So just simply call on the message one, which is the enter numbers to tell the user to enter the digit that he or she wants to shift. And we set our value for AX back to 0. And we call on the read integer so that we could get the value and store it in our input one. Next is we call on the second message, which is the enter the number of places to shift. This one. And we just call print string so that it'll print out in our program. Then line 40, we have this reads the second input entered and stores input in input 2. So this part just simply gets the inputs from our user and store it in their designated labels. Here in line 43, we have this move CL input 2. So this is the LSB of the counter register. In line 44, we have this move EAX and we store the value of EAX from our input 1. Here in line 46, we shift right with the value of CL. So the value of CL is the second input. And now the answer here is the input 1 shifted to the right for CL times. And the result here will be stored in our right shift. In line 49, which is simply doing what we did here, but this time this one is for the left side. So the input 1 is stored in our AX. So the value of EAX now is input 1. And we need to shift left in CL times, which is the input 2. And in line 51, we have this left shift EAX. So we just simply store the value that we got here in our left shift. In line 53, we have here the printing out of the results. So we have here, we just simply call on the first value. So as you can see here in our sample problem, we have this 5, left shift 1 is 10 and right shift is 2. So we are aiming to get this kind of result. So in line 55 to 56, just simply call on the number, the first value. And we call on the left operation, which is a string that we have here from our dot data, this one, in line 16. And we just simply print out that one. And in line 40, it's the second input entered stores put in input 2. No, not that one. This one. So we just print out the left shift operation. So this one, that 2 less than signs. And in line 60, we print out the value of number of shifts, which is the input 2. This one. And message C, which is the word is. And the left shift is the value for our left shift. Like this one. So this is supposed to be the 10 value. In line 58, we just simply copy this one, but this time this is for the right shift. And the only difference here is the right operation that we've used. Like in this one, we have this left operation and the value for our result, which is the right shift. And just call print a new line. And here, this is the exit part, so preparation to leave the program. And we're returning the values back to zero. So let's see if this program works by compiling it in our and we compile this one, calling it our driver.c. So let's test. Let's copy this one. So we have the enter number 5 and the number of days to shift is 1. Okay. And now we have here answer. So let's try another number. So let's try 8. Then 2. So as you can see here, the left shift should be 2 raised to y, which is the 2. So 2 raised to y is 4. 4 times 8 is 32. And this for the left shift. And for the right shift, we divide this value, which is 4 to 8, and that gives us 2. And that's all for this video. Thank you for watching. And before this video ends, I just want to thank Josh for staying by my side while doing this code. So thank you.